One problem we have while iterating through red-green refactor is determining whether or not our code has been tested enough. This is a really common question in practice and one that's really important. When we're testing our code, we have a few high-level goals and some explicit non-goals. And having a clear understanding of what those are important when you embark on testing. First, we want to ensure that our code correctly implements its specification. That is, does it do the right thing? Next, we want to try to find defects in our implementation. Right? So if we've made mistakes writing the code, can we find those before we ship? And finally, we want to understand where we can expect to have found defects. Right? Because we can't expect to have found all defects, as we know from Dijkstra's comment earlier that testing can show the presence, not the absence of faults. So we want to know where we can at least have an expectation that we could have found the faults in our system. And this just reinforces our explicit non-goal, and that's to ensure that our system is bug-free. Right? We can't do it because there just isn't enough time in the day to be able to make sure that there are no faults in our system. Right? Ultimately, we want to be able to build software systems that are useful for people and that we can ship. What we want to do here is to maximize the quality of the code within our system while maintaining a shipping cadence. And one thing that we want to help make easier for developers is build an understanding of what tests they should write before they feel comfortable shipping. And this is really what Whitebox coverage-guided testing is all about. Coverage is a software development metric that measures the proportion of the system being executed by a test suite. Various coverage metrics exist, and each of them defines a specific technique for measuring which parts of the system have been executed by the suite when it's run by the developer. Generally, coverage is reported as a percentage. The coverage percentage is the amount of covered versus overall code within the system. There are two broad categories of coverage used in practice. The first is flow-independent coverage. This is probably the most commonly used type of coverage in practice because it is cheap to compute and really easy to reason about. What flow-independent coverage does is it makes sure it executes each piece of the system and ensures that it is capable of executing successfully. So the first kind of these is block coverage. Block coverage measures the proportion of blocks in the system that can be executed by the test suite. Since a block can contain many lines of code, this is one easy way to split up the program into parts that are generally smaller than methods but are coarser than lines. Line coverage measures the proportion of lines within the system that are executed by the test suite. So this is also really intuitive to think about because you can just look at the code line by line and reason about whether or not they've been executed by the test suite or not. Finally, statement coverage measures the proportion of statements in the system that are executed by the test suite. This is very similar to line coverage, except that many program statements, for example, compound ifs or looping conditionals, often contain multiple statements on the same line. So in statement coverage, we want to break these up and make sure that all statements on a line are covered rather than just hitting the line itself. The next category of coverage is called flow-dependent coverage. This type of coverage is all about making sure the different pieces of the code are able to execute together. Flow-dependent coverage is more expensive to compute, so it is less commonly used in practice, and is a little bit harder for developers to reason about. At the same time, flow-dependent coverage gives us a little bit more insight into how stringently we've executed our system. So branch coverage is one kind of flow coverage. And this is where we check to make sure that we've executed both halves of every branching statement. For example, that we try both the true and the false branch of an if statement. Next, we have path coverage. Path coverage ensures that we execute all paths in the system. So if we have two if statements, we don't just execute true and false for each branch, but we also execute the combinations of true or false. Finally, there's MCC coverage, which is a complex extension to path coverage that ensures that all statements are also independently evaluated with respect to the outcome of a function. This kind of coverage is mandated in some safety-critical systems, but is extremely hard to use in practice. Now, there are more kinds of coverage than these 6, but these are some of the most commonly used metrics in practice. Today, we'll specifically talk about line, branch, and path coverage. Coverage-guided testing is an iterative process. What we want to do is first identify some uncovered code. Next, we want to design a test case that executes that code. Then we write a test and execute it to make sure it passes. And finally, we repeat until we've met some desired coverage goal. So for a project, we might say that all new code that's committed to the version control repository must have 100% line coverage. Or other projects might say that they require 80% branch coverage on all new code. The type of metric that you use as a stopping point will vary from team to team and project to project.